This is the crash site of a Chinese rocket, one of several that have fallen dangerously close to villages over the years. China's most recent launch in June 2024 saw yet another first-stage booster from a Long March rocket descend on Chinese soil. This family of rockets has been the backbone of China's space agency, yet their uncontrolled re-entries and the risks they pose to citizens have raised alarm. While the West tends to focus on the activities of NASA and the European Space Agency, or ESA, China's space program has quietly been making impressive strides, though with some controversial engineering decisions. Before we move on, don't forget to subscribe to Space Explained. Rockets falling on populated areas and spewing toxic gas aren't accidents. China has intentionally designed its first-stage boosters to land within its own borders. While this decision draws attention, China's space agency has been making rapid advancements, launching its own space station, beating the US to the lunar South Pole, and even landing a rover on Mars. Yet, despite these successes, many in the West are unaware of the risks these missions pose to Chinese citizens and the broader implications of their space program. China's space activities have a strange, dangerous side, starting with where they launch rockets from. With an extensive coastline, China could launch from the southeast, taking advantage of Earth's rotation to boost velocity and safely drop rocket stages in the Pacific. Instead, they often launch from Xichang Satellite Launch Center deep in the mountainous center of China. The reason? Security. These launch sites were originally built as military bases for testing missiles, and placing them inland protects them from foreign attacks. But this also means rockets have to fly over populated regions. This risky choice was tragically highlighted in 1996 when a Long March 3B rocket carrying a U.S. telecommunications satellite veered off course moments after launch. The rocket crashed into a nearby village, reportedly killing 6 people. However, many have questioned the accuracy of this figure. Beyond immediate casualties, these crashes carry long-term health risks. The early Long March rockets, and some still in use today, rely on hypergolic propellants, chemicals that ignite on contact without the need for an external ignition source. While reliable and useful for space missions, these fuels are highly toxic. Hypergolic propellants like unsymmetrical dimethylhydrazine (UDMH) and nitrogen tetroxide are dangerous to humans. When they combust, they release a toxic orange-brown gas that can cause severe lung damage and other health problems if inhaled. In fact, exposure to these chemicals can lead to long-term illnesses, including cancer. Despite this, the Chinese Space Agency continues to use these fuels. When rockets crash or stages fall back to Earth, villagers in the affected areas are exposed to hazardous chemicals. The government does provide warnings, telling residents to move if they see falling debris, but little else is done to protect them. China's space program has not only raised concerns for its citizens, but also for the international community. In 2007, China shocked the world by destroying one of its own satellites with a missile, in a show of military strength. The resulting space debris posed a significant hazard to satellites and space missions. In response, the US passed the Wolf Amendment, which forbids NASA from working directly with China on space projects. This led to China's exclusion from the International Space Station, ISS, the symbol of global space collaboration. Rather than slow down, this isolation pushed China to accelerate its space ambitions, launching its own space station and human spaceflight program. In 2011, China launched its first experimental space station, Tiangong-1, which was intended to last only 2 years, but remained in orbit for an additional 5. Tiangong-2 followed in 2016, further refining China's space capabilities, including refueling techniques and cargo transfer. By 2021, China had constructed a full-fledged, permanently crewed space station, Tiangong, assembled with 3 modules. Though smaller than the ISS, Tiangong represents a significant achievement for China's space agency, featuring 2 robotic arms and advanced scientific equipment. Its rapid development showcases China's determination to become a space superpower. But China's technological progress hasn't come without challenges. The Long March 5B, China's heavy lift rocket, has raised serious concerns. Unlike most rockets, which burn up their smaller upper stages upon re-entry, the Long March 5B's massive 21-ton core stage reaches orbit, eventually falling back to Earth in an uncontrolled manner. This design choice has led to several alarming re-entries. Between 2021 and 2022, 3 Long March 5B rockets made uncontrolled descents, causing the 4th, 5th, and 6th largest uncontrolled re-entries in history. While the odds of these stages hitting a populated area are low, their massive size makes them a dangerous hazard. Debris from one re-entry landed in the Ivory Coast, while another led to the closure of airspace over Corsica. International space organizations have criticized China's handling of these re-entries, with NASA's administrator stating that spacefaring nations should minimize risks to people on Earth. Despite this, China has not altered its rocket design. While the Long March 5B has its flaws, China has made strides towards reducing its reliance on hypergolic fuels. The newer Long March 5 rocket uses kerosene and liquid oxygen in its first stage, and liquid hydrogen and oxygen in its second stage, representing a shift towards safer and more environmentally friendly technologies. Despite these questionable choices, China's space accomplishments are undeniable. They've built their own global positioning system, Beidou, after a series of geopolitical events highlighted the risks of relying on the US GPS system. Beidou now boasts the largest satellite constellation in orbit, even surpassing the US system. However, Beidou's two-way communication system has raised concerns about privacy and surveillance, as it could allow the Chinese government to track users. Taiwan, for instance, has banned its use on military vessels. China has also pushed boundaries with Mars exploration. In 2021, it successfully landed its Tianwen-1 mission on the Red Planet, becoming the first country to land a rover on Mars on its first attempt. The rover's significant discovery was finding evidence of ice beneath the Martian surface, an essential step for future human exploration. Similarly, China's lunar program has been highly successful. From mapping the moon's surface with the Chang'e 1 and 2 to becoming the first nation to explore the far side of the moon with the Chang'e 4, China has established itself as a leader in lunar exploration. In 2020, Chang'e 5 brought back lunar samples, and future missions aim to establish a research base on the moon. China has also embraced the private sector, with over 70 commercial space companies now operating domestically. These companies are helping China innovate faster, and the nation is rapidly closing the gap with other spacefaring countries. Despite criticism, China's space program is pushing boundaries, driving innovation, and, as history shows, competition between nations often accelerates technological advancement. While China's space program is progressing at an impressive pace, its decisions regarding rocket safety, transparency, and human risk remain serious concerns. Nonetheless, China's growing ambitions in space exploration are undeniable, and its impacts on the future of space will be significant. If you liked this video, please like and subscribe for more content like this.